differential equations. Okay. So let me explain what it is. You know what is an equation, right? There is a difference between equation and inequality. So what do you mean by equation is what we need to see first. If I give you an expression like this, bx plus c, what will you talk of? What will you say this is?
Polynomial.
It is a polynomial. Right. When can this polynomial become a quadratic equation?
When it is equated to something.
When it is equated to 0. So the general form is like ax square plus bx plus c. If there is an equal to symbol, yes, it becomes an equation, right? Then we call it as quadratic. So here you would have called as quadratic polynomial. Here we call it as quadratic equation. Okay. Similarly, if I give you sin x, it's a trigonometric function. If I give you sin x is equal to 0, it becomes trigonometric equation. In a similar way, what do you mean by differential equation? So what do we mean by?
It will also be equal to something.
What will be equal to 0?
Equating it to 0.
Yes. See, for example, if I have a variable y, then we just call it as variable and leave it, right? If I differentiate this variable with respect to x, I'll call it as a differential coefficient. If the same differential coefficient is equated to 0, if you use an equal to symbol, then it becomes a differential equation. So this chapter is all about framing a differential equation or solving a differential equation. I'll explain the difference between both as we progress through each exercise. Are you guys clear with what exactly does a differential equation mean?
Yes, sir.
Yes, sir.
Okay. Yes. So this is a very, very simple aspect. So that's what they would have given. We are already familiar with the equations of the type, this thing, there's a trigonometric equation, there's a linear equation in two variables. In a similar way, if you consider an equation like this, x into dy by dx plus y is equal to 0, then this equation is called a differential equation. Okay. Now, see, in the differentiation chapter, I would have already introduced this part. I would have told you that dy by dx can be written as y dash, or it can be written as y with a dot on top of it, or it can be written as f dash of x. Right? Do you guys remember this?
Yes, sir. Yes, sir.
Or this can also be written as derivative of f of x. Okay. So in this chapter, what we do is we use it in the form y dash and y double dash. If you do the second derivative, d square y by dx square, then this will be y double dash. Right? So we shall prefer the use of following notations like dy by dx is equal to y dash, d square y by dx square is y double dash, d cube y by dx cube is equal to y triple dash. So it keeps on going like this. Okay. So for every differential equation, there are two important terms to be kept in your mind. One is called as the order of a differential equation. Okay. So let us take an example. If you have dy by dx is equal to e power x, means the question would have been y is equal to e power x. If you differentiate on both sides, dy by dx is e power x. I hope you are able to understand this, right? So dy by dx is e power x. So I'm able to get a differential equation. Correct? So this differential equation has a parameter called as order associated with it. So what do you mean by order is the number of times the differential equation is, the number of times the function is differentiated. So here the given function is y is equal to e power x. dy by dx is equal to e power x means how many times did we differentiate?
One time.
One.
We differentiated it one time. If suppose I give you an equation like this, d square y by dx square plus y is equal to 0. If I ask you what is the order of this differential equation, what will you say? Irrespective of whatever you have,
2.
you need to look at all the differential coefficients. whichever differential coefficient has the highest power, or whichever is, see, the highest order derivative, see, sorry, order of a differential equation is defined as the order of the highest derivative of the dependent variable with respect to the independent variable. So when you differentiate d square y by dx square, means the dependent variable is y and the independent variable is x. I hope it is clear. Okay. So let's take example. This one is what? This is of second order. What about this thing?
Third
3, sir.
order.
So the answer is 3. Is the 3 because of this or this?
Left.
Because of
D
d
cube
x
y.
cube.
First one, d cube.
It is because of dy by dx. Okay. So here what is happening is order and something, that power is there. No, the power also has another name. You need to be careful. Okay. It is because of the number of times the function is differentiated. We are able to say that the order is 3. For example, if the question had been given like this, d square y by dx square plus dy by dx the whole power 5 plus y is equal to 0. Order.
2.
2.
It is still 2 only.
2.
Okay. Order is 2. That's right. Now the next parameter that is associated with the differential equation is its degree. Okay. So the degree of a differential equation is a, 1 minute, I'll show you the reference. See, generally degree of a differential equation is the power to which the highest order derivative is raised to. Okay. So I'm repeating it. Degree of a differential equation is the power of the highest order derivative. For example, if you take this expression, then what is the degree? What is the order first? Tell me.
2.
2.
Order is
3.
2.
3.
And what will be the, sorry, order is 3. Degree will be?
1.
The degree is 1. Because you should not look at this 2 and get confused. What should happen? D cube y by dx cube raised to the power 1. The highest order's power is what is going to be the degree. Similarly for this one.
1.
Degree is 2.
Order is 1.
Order is 1. Degree will be
2.
What about this thing?
Order is
Order
1.
1 degree 1.
Order and degree 1.
Order is 1. Degree?
1.
Okay, there's an important point. Degree is not 1. In this case, degree is not defined. I'll explain why it is so. Okay, we need to read an important point. So, order is defined for all the differential equation. While you're trying to define the degree for a particular question, there are some important checkpoints to be looked after. So, let me read out what is given. We observe that equation 9 is a polynomial equation in y triple dash, y double dash, and y dash. Is it there? So, it's a polynomial equation in y triple dash, y double dash, and y dash. And equation 10 is also a polynomial in what? In terms of y dash, first derivative. So, degree of such differential equations can be defined. So, make a note of it. If you're able to form a differential equation, okay, if you're able to form a differential equation which is polynomial of a differential coefficient, you can define the degree. But what is happening with the 11th one? Let us observe. See. So in the 11th one, it is not a polynomial equation in y dash, and the degree of such differential equation cannot be defined. Why it is not a polynomial of y dash is because, observe the difference I'm going to show. Dy by dx plus sin y is equal to 0. Okay. This is a polynomial. Okay, there is a polynomial equation in terms of what? In terms of y dash. Whereas if you have dy by dx plus, you have any of the functions. It can be any function. It can be sin x, cos x, tan x. That is, it can be a trigonometric function. It can be exponential function. It can be logarithmic function. Any function should have only the dependent or the independent variable inside them. For example, if it is sin y, sin of what does it have inside? Sin of, it has a dependent variable inside. For example, if I give you a question like this, dy by dx plus sin x equal to 0. Then can we define the order and degree for it?
Yes.
Degree is going to be how much?
1.
1.
Degree is 1. Whereas if I have dy by dx plus sin of dy by dx, can we define the degree for it?
No, sir.
What is the reason for it? Because sin is
Dependent.
either having a dependent or independent variable. It is having a differential coefficient inside, which is not allowed. Okay, so degree cannot be defined for functions which are not following the polynomial equation condition. So if you do few examples, you will understand. Okay.